is the day 6 of coding. We are solving 189 rotate array question from top interview 150 questions list. Let's get started. The question says, given an integer array nums, rotate the array to the right by k steps where k is non-negative. And we have some examples given here. First example, we have an array of 7 items and k is 3. And the output should be in like this. So we have the explanation. When we move one step to the right, we take everything and move it by 1 index. 1 is moved to the second place, 2 is in the third, and so on and so forth until where we have 7. 7 is placed to the beginning of the array, as if like this array is like instead of, we cannot just add another index here. It would not make sense. It would increase our array size and we may end up like with 1, maybe right here, or some number. So when you run out of the array length, we just keep pushing to the end, to the beginning. So here as well, in the second step, we had 6 here, we move it to the beginning, and then we move 7 by 1, 1 by 1, and each other element is moved by 1, and at the third step, the same logic. We moved everything by 1, and the element at the end moves to the beginning. And we have another example where we have 4 numbers, k is 2. At the first step, we move all of them by 1 to the right, and the second step, we do it again, and we end up with this array. And if we look at the constraints, nums array can be between can have at least 1 element or 10 to the power of 5 elements. And the numbers inside the array can be within this range, and k, the steps that we should move to the right, can be either between 0 and 10 to the power of 5. Follow-up. Okay, we also have a follow-up. Try to come with as many solutions as you can. There are at least 3 different ways. Could you do it in place with constant extra space? Okay, I believe the explanation is pretty straightforward. So we get an element, and also here, do not return anything, modify nums in place. It means we just modify the input that we are getting, and we don't have to return anything. So we have this array and some k for 3 here. We can do it in one step, like instead of doing it until k move 1 by 2, we can just say do this in one step by doing like moving everything by 3 steps. We take 1, we move it to the where 4 should have been, like we take 4, move it right, and so on. So the output, let me also place the output here. Okay, oops. Let's start with the first approach. It can be easier because what we can do is we can take this array and create a new array. A new empty array, or array with the size of the existing array, depending on the language you're using. For JavaScript, I can create a new array and then loop through the first array. Loop through the nums to fill it in. What I mean is, like, first time you loop through the last k elements that you should replace first. Like if it is k3, you loop through the last 3 first, add it to your empty array in that order, like you add 6 and 7, and then you loop through the beginning of the array by adding like 1, 2, 3, and 4. So this is the first approach, and at the end, since we are not returning anything, you can just say nums now equals to this new array, which will okay, I hope the explanation is clear, which will give us the space and time complexities of time complexity will be a big O of n, because looping through the array, like we are looking at the array as if it starts with here and then as two different arrays, and looping through every element that takes a log of n, and addition to the new array, like we are pushing every time we add one element to the end of our new array, which results in big O of 1, and together it will be big O of n time complexity for our program. And for space, for this solution, it will be big O of n again, because we are taking a new array that's the same size as nums, which means we are using the same space as the nums. So this is big O of n, where n is the numbers, like length of that array, length of nums array. So this is the first approach we can take, and the second approach that I found very common in the internet and like in the solution section is reversing the array. It can be clear when you look at here and the solution. We need some steps. Let's just say this, and it should end up like this. The first step is you reverse the array. Okay, now our array would look like this: 7, 6, 6, 5, 4, 3, 2, and 1. Do you see any similarities between this array and this one? If you look closely, you can see that both of the arrays have two parts, like this part reversed and this part reversed. So the next step, we reverse first k elements, where it would be 5, 6, 6, and 7. And as you have already guessed, at the third step we reverse last all the remaining elements, like elements starting from k, let's say k's element, which is like from k, I would say, because like we should start from this index 4. Okay, so this time we reverse the end of the array, 1, 2, 3, 4, and we end up with the result, with answer matching our result. That's how like most of the approaches. And the time and space complexity for this one would be the first time we reverse the array, it takes big O of n time, because we go through every for the reverse algorithm, it is something like that. You start with the first one and takes the last one, you switch them, and then you start with the second one, you switch last to second one, like last one. You start from counting here, right? 2 and 6, and then you start with 3 and 5, and at the end, when you reach the end, or when your two pointers, like start and the end, are the same, you stop, It is actually n divided by 2 because you reach here and all the end of the array is already sorted because when you swapped it was reversed. And here also we are reversing like the first part, this part, and then here we are reversing the end. All in all of them become big O of n time. And for space, since we are not using any space, we are just taking the array, reversing its indexes, items, it's big O of 1. And the third approach, which actually was my solution when I solved it for the first time. I didn't know the second approach, honestly. What I did was moving. Let me explain. Move elements by k until you loop through all the elements. Let me explain. So I have this array and k equals to 3. What I wanted to do, what I did actually is I start at 1, I move it by 3, which means 1, 2, 3, I replace it to 4. And let me show step by step. We will have 7 steps because we swap elements 7 times. We move elements 7 times. The first time we take 1, we move it to here. And now we remember that we had 4. There is also a variable that remembers which number we should move right now. And we look like 4 should actually be here. Okay, 1, 2, 3. Yeah, 4 should be here. We remember like 4 was the one we should move right now. We put 4 here and we say 7 is the number we should find a place right now. And since we start here, we add 3 steps, which I had also like which should actually be at the beginning of the array for that one, and for this approach as well, and for everything. K, for finding k, as the first thing is like k can be bigger than the array length, because here in constraints it doesn't say it's between nums.length. So that means for finding the true shuffle, like true k, that's less than the array length. For example, if it was 10, we had to move everything by 10, which also will result in this answer. If it was 17, we will still get the result. Can you see the let me just can you see the something that unites these numbers all? So the answer is k is equal to k divided by the array nums.length, the remainder of nums.length, because like 3 divided by 7 is 3. 10 not divided by 10, a remainder of 10 divided by 7 is 3, and the remainder of 17 divided by 7 is also 3, which gives us the k within the range of nums.length. And here, we come back to our solution. Now we are at here, and the number we need to find a place for is 7. We start from the beginning of the array. We find that it is this place. We replace 7 here, and we remember that we have 3. I believe I skipped one. here we remembered 4, and it was like this, as you can see. And now we are at here, it is 7. For consistency, let me just take and write every step when it counts. Yeah, here we wanna remember 3. We put 7 here at this stage, and at this stage we put 7 there, and now we were here and we should go to 3 steps. We come here and we say 3 should be here, remember 6. And next step, this time 6 should find its new place. It was here, we move it by 3 and we place it here, and we say now remember 2. This is how I did actually. And for 2 we move it by 3 and find that it should be actually here, and say now remember 5. I hope it is not confusing for you. For 5 it was here, yeah, remember it was here. Now the first place, its true place, is actually here. We put it here 5 and we skip. The condition for switching, breaking the loop, is the start of our start index is the same as our current index. That's how we skip. We say, yeah, everything has been reversed at this stage, and it took us 7 steps, which gives us the time complexity of big O of n, and space complexity of big O of actually 1, constant space. That's how I did it. And you may be asking, what if we have a case when there are, let's say, when there are 4 numbers. Let's see the case when we have 4 numbers and k is 2. What will happen? If you have caught this mistake, this edge case, you are very attentive, I would say. Let's start with 1. Here we start with 1 and we move it by 2 and we replace it here, and the number we should move is now 3 at the first stage. And we take 3, we see that we have 3. 3 was here, we move it to here, we say here, for example, yeah. And at this stage we again have 1. If we keep the same logic, we keep repeating ourselves, and the program will never exit, right? We move 3 to 1, 1 to 3, or if we exit as when start index is the same of our current index, the answer is wrong. So the logic I added was, if they are the same, if start index is the same as current, I also added something for iteration count. For example, here we have count of iterations 2, but here we did 7. So I added another condition where it says iteration count less than the nums dot length, because we know that it takes n space at least to give the right answer. If that's so, I would move my current by 1 index. So I would say, yeah, we come back, but iteration is 2. So let's just take the next element, which is 2, and start moving it. So the next type, we have 2 moved here. We remember 4, and at this stage we say 4 should be moved by 2, and 4 comes here, and again we are at the start index. Here we say start index plus plus as well, so that they are the same again, but this time iteration count is not less than the number's length. We are at the 4th iteration, which means we can just return the answer. I hope it was clear. That's how I solved. My approach may be a bit tricky, but it always works. You either end up at the same starting index with full iteration, or you move your starting index, and at the end, after all, you will end up with the answer with big O of n, because you iterate through all the elements, and space complexity of 1, constant complexity, because we don't use any other array, dictionary, or any data structure to store, except we will have some variables to track current and start indexes. That would not change, like even if the array size changes, we will still have the same variables, which means we will have a constant space. Okay, time to code. Let's code. Actually, we also have a fourth approach. I would say that's very for JavaScript. That is just like takes the array, splice. There is a function splice that will cut our array and return the part that has been cut out. Like I can say splice nums.length minus k, starting from k, which means starting from this array, splice k elements. And then we also have in JavaScript unshift function, which will add to the beginning of the array, and we can give like 2, 3, 4, and it will add 2, 3, 4 to the beginning of our array. We should say like also do not forget nums.unshift, and instead of 2, 3, 4 we want to add this, but here we also want to spread it. So splice returns as an array of 4, 5, 6, 7 when we give k as 3, and then spreading it will just give us the answer 5, 6, 7, which is accepted by unshift function. Time and space complexities of this one is also big O of n. For splice takes big O of n, and shift takes big O of n. So we are doing these iterations one after another, meaning that the overall is actually big O of 2n, but we remove the constant, it will be big O of n. But a big O of n, and space complexity would be big O of 1, because here, if you look at this, is just this one line answer. One thing to note is like we need to make sure that k is actually k remainder of k divided by nums.length. That's one thing we need to take care of. So these 2 lines of code would solve our problem with this space and time complexities. Let's start with our fourth approach. Okay, because it's very easy. Splice k, and let's run. I hope the spelling is correct. Oh, I should actually say let. And splice is not defined. Okay, nums.splice. Here comes my syntax errors. Okay, is actually I am so dumb where k is given. Splice, I have written it wrongly. And submit. Okay, as you can see, it works if you write correctly. So splice, I was pronouncing splice, but I wrote spiles. Okay, so that was the first solution. Let's go back to the third approach that I used. Third approach, moving by k. Here, what we do, we will have a iteration count, which will be num.length. Actually, you can stop, pause the video here, and write your own coding for these approaches. Otherwise, I will keep coding. Okay, we will have iteration count, and we will have start index, which will start at 0, and we will also have something to move our item to place, let's say, that will take care of these numbers. Like every time we knew what we wanted to, what number we should place, so that's the number we want to place. For the start, we start with nums.0 or nums start idx, item to place, and this. And we also want to take care of current index, which will also start at 0. And we will have a while loop, which will check while iteration count is less than nums.length, which means we have not iterated through the array. We want to check the first check we do. No. Okay, I also okay, we have k and everything. Okay, right here, what we do, we wanna move this element by k until the iteration count is finished. We start with, we will have a temporary variable to store the current, for example, when we start at 0, we want to move it to the next k. First of all, I want to have next idx, which says k divided by array length. Oops, let me write my pseudocode or else I may forget. Okay, move by k steps. That would be let next idx, which takes our current idx, adds k to it, and then we want to get the remainder from nums.length. I didn't just add k because I want to know the next index I should place 1 to. For example, if it's 0, I add 3, and then it gives me index 3. But if it's index 3, I want to get 3 plus k, which is 3 again, a remainder of the length divided by 7, which gives a remainder of 6, which will be this index. And when we come at 6, and index 6 plus 3, which will be 9, 9 divided by 7, the remainder will be 2, which will give us this index. That's how I want my program to work. I get the next index, and what I do, I will also have a temporary variable to store the data in the next index, which will take something like nums.next index. So at the stage 1, it stores, when we move 1 to 4, it stores 4 temporarily. And the next, we do the swapping. Or replacing. Actually, we are not swapping, we are replacing. By replacing, we say nums next index should actually be num's current index. Okay, and here after replacing we update indexes. I can actually say current ID, not current index. Okay, let it just be here, current index. Okay, item to place. I say item to place is now this temporary variable. Oops, temporary variable. This is item to place, and actually here it should be item to place. Okay. We replaced them. We updated item to place. Okay, and we also need to update our current index. Our current index should be our next index, because we move when from after the first iteration. We are now not at the second index, but we are at the index that we just place it. We are at here and we are looking for the next index to place, and that's how it works. And also here we need to decrease the iteration count. Minus. Okay, I just want to say iteration count starts at iteration count here. If we start at 0, we will say we just iterated once and please plus. And the case where our current index and start index are the same, we will do if current index is the same as start index, we need to check it here, and iteration count is the same as nums dot length. Actually not same as, meaning that we have not iterated through. We will say current index should be updated, start index should be moved by 1, and item to place should actually be new item, which is at the new current index or new start index. That's how it should work. And yes, that's the logic we do, and here we update. Only after updating we add it. Okay, let's run. Okay, we have a problem here. Current is not I see, it's current IDX. And also here we oh, it works here. Okay, just run. This case is passed. Let's submit. Okay, this one also passed. They are pretty similar with 1 megabyte difference, I see. Okay, and now we can go to the second approach. We are counting from the start. Second approach was this reversing the array, then reversing first k elements, and reversing elements starting from k till the end of the array. So these are the steps. This is pretty straightforward compared to my lengthy approach. Yeah, but both of them work. First time, we want to have another function that does the reversing to keep things clean, and it takes the start and index and array, and it returns, like, it doesn't return anything, it just modifies array in place. What it does is swap left, let's just say left and right, left and right until left less than right, meaning that when they are the same or when they change values, we should just stop in the middle, as we did. Like, we stopped here when they are the same, which means we have already reversed. And this is how we do it. While left is less than right, we are taking indexes. Actually, when I say left, it is an index, not the actual element in the array. We should have a temporary to store. In Python, you can just swap without any temporary variables, but in JavaScript, you have to have this temporary, which, let's say, takes our right element. And now we say array.right should be array.left. And at the end, I say array.left should be our temporary, which was storing our right. So in that way, we end up like, if we give 1 and 7, we are keeping 7 in the temporary. We are saying 7 should be replaced by 1, and we are saying 1, like the left element, should be replaced by the temporary, which is 7. Okay, and the next step, it should also say left plus plus, like we move left by 1 to the right, and the right should be minus minus, we move right to the left by 1. Yeah, we decrease left right, we increase left until we reach this condition. Okay, we have our reverse function ready, and now we will use it for every step. First step, we reverse the array, meaning that we start from 0 till the nums.length minus 1, and nums array, we pass the array. Okay, the first step is done this way, which gives us the array, reversed array of this. And the second step, we reverse first k elements of the new array, which means we start at 0, but we end at nums length minus k. And for k, for reference, we should also say k is actually equals to remainder of k divided by nums.length to get the k between array lengths, valid k, let's say. Okay, so right here we have it. And the last stage, we reverse elements starting from k, meaning that we start from k till length minus 1. Okay, so this is how we do it, and at the end we have the array ready for us. Let's run this project, the solution. Okay, I have a wrong case. What went wrong? Let me see. The first stage, let's console log nums to see what went wrong and which stage. Okay, first stage, it is working fine. Second stage, oh, okay, I see why. I should say nums is now equal to, because reverse nums, and okay. Okay, and let's just return nums array, run. Okay, the first stage, everything's fine. Second stage, We are reversing 3, 4, 5, 6. That's the problem. We are starting from 3. We should not go until 3. Minus k minus 1. Oh, that should solve it. Okay, again wrong. This time we have it correctly. Oh, I see. We shouldn't have 5. Oh, I see. Until k minus 1. And now it works. That was my logical error. Like, it should have been k elements from the start instead of like length minus k. It should work this way. Let me just remove, or even we can go back to the old version where we didn't return anything, just replaced array in place in our reverse function, and it will still work. Okay, that was it for this second approach, and I don't think we need to cover like the first because it's not what we actually want. But yeah, basically you iterate through the list and add values to the new list. That's pretty straightforward. Okay, thanks for watching. Subscribe and keep coding. See you on day 7 tomorrow. Bye.